Hi, everyone. For those of you who don't know me, my name is Tom Keefe. I'm the category manager for DirectView LED here at Exertis Almo. Today, I'm bringing you the first of a series of training videos on breaking down DVLED. I would also encourage you to visit the Exertis Almo blog site to access these trainings in a written format. Simply visit blog.exertisalmo.com and search Tom Keefe, and all my past blogs will be displayed there. Many of them do focus on DirectView LED. The purpose of these training courses is to give you a basic overview of DirectView LED. The information provided here is designed to give you a working knowledge of the technology so that you are aware of what DVLED is and how it's different from other display types. This way, you'll have a baseline understanding of the basic components of a DVLED system so that you can be confident when having conversations with a customer, or anyone really, about DVLED. The title of this first module is Cabinets and Modules and Panels, oh my. Some of the topics we're going to cover are: what is DVLED? Why DVLED? What are the components of a DVLED video wall system? The importance of pixel pitch and viewing distances? And finally, I'll briefly break down the definition of cabinets, modules, and panels. So let's get started. I didn't sell DVLED video walls for a long time because I didn't understand how to talk to customers about it. My first formal training on DVLED was well over 10 years ago. Frankly, what I remember most is how confused I was walking away. It was a brand new technology that was very expensive and it promised to be the next wave in display technology. My expertise up to that point rested squarely within the confines of projectors and large flat panel displays like LCDs. Needless to say, following the training, I was not able to hit the ground running. Fast forward to 2025, and DirectView is now the king of large format. If I'm not offering it, I'm going to be left in the dust by my competition. The good news is that DVLED is quite simple once you grasp a few simple concepts. So let's begin. What is DVLED and how is it different? Let's start with the name. DVLED stands for Direct View Light Emitting Diode. It's a mouthful. So for the purposes of this discussion, I would describe LED as a tiny dot that lights up red, green, and blue. When you put hundreds or thousands or millions of them together, they're going to make a great, big, bright, colorful image. Why is DVLED so popular now? And how is it different from other display technologies like LCD-based video walls? First, it's ideal for more complex and creative, custom-designed video walls, since the technology has no limits on overall size, shape, resolution, or aspect ratio. There are no visible grid lines from bezels, just one seamless image. Many all-in-one offerings are now available at competitive pricing, even versus larger LCDs. It has a much longer lifespan than LCD and performs consistently over time. Generally speaking, it provides superior color uniformity, brightness uniformity, and image quality. And finally, it's ideal for 24/7 operation. A DVLED video wall system is typically made up of a series of square or rectangular panels, which come in a range of different physical sizes that are integrated together to create the desired image footprint or size and shape. Content is driven to the wall through a video wall controller that converts the video signal to display properly on the integrated wall. The video wall signal is converted from HDMI and sent to the display over Cat5 or 5E cables. Similarly, LED walls commonly require more than one power circuit depending on the size and output of the wall. Often, a video processor from brands such as TV1 are used in addition to the controller to perform more creative functions, such as managing content from multiple sources, screen windowing, and custom image sizing. However, a controller is a requirement for every video wall, while a processor is not always necessary. Every video wall will have what's called a pixel pitch. For LED displays, pixel pitch determines the quality and clarity of the image at a fixed distance. A smaller pixel pitch means the pixels are closer together, resulting in a more densely packed pixel grid and higher image resolution at a fixed distance. A larger pixel pitch, on the other hand, results in more space between the LEDs and lower image quality at the same relative fixed distance. Displays with a low pixel pitch are sometimes called fine pitch LEDs and are often designed for indoor use. In the world of projectors and LFDs, we talk a lot about resolution: 720p, 1080p, 4K, UXGA, etc. From 30,000 feet, this tells us a lot about how well defined our picture will be. Basically, the higher the resolution, the more dots or pixels will make up that image. The more dots you have in the same relative area, the better the picture appears at a given viewing distance. Think paint by numbers, if you're familiar with that. The more numbers included, again, in the same relative sized canvas will result in a more sharply defined image. Pixel pitch indicates how close together the dots will be, as mentioned. So for example, an LED wall with a pixel pitch of 10 means there will be 10 millimeters from center to center from one dot to the next. A pixel pitch of 2.5 is 2.5 millimeters between dots, and so on. As of this moment in 2025, many DVLED manufacturers are offering pixel pitches as fine as 0.7 millimeters. To give you a point of reference, a 100-inch 4K traditional LCD TV will give you an approximate pixel pitch of 0.45 millimeters. When selecting an appropriate pixel pitch, it's very important to know the viewing distance. The most important spec to consider is the closest viewer. Average viewing distance and furthest viewing distance are also useful to know. The most popular and generally accepted standard that is currently used by vendors and others when suggesting an appropriate pixel pitch is distance divided by 10. This means that to select the right pixel pitch, you'll need to take the distance in feet of the closest viewer and divide by 10. The quotient should get you in the neighborhood of what an appropriate pixel pitch selection would be. For example, if the closest viewer is 10 feet away from the display, then the appropriate pixel pitch would be 1.0. Similarly, if the closest viewer was 25 feet away, an appropriate pixel pitch would be 2.5. Finally, let's focus on the title of this session and discuss the terms cabinets, modules, and panels. So a simple formula to remember is modules plus cabinet equals panel. The cabinet is the square or rectangular chassis or frame that houses the electronics and provides structure to the video wall. Modules, sometimes referred to as pixel cards, are the square or rectangular sections of LEDs that make up the picture and are generally affixed to the face of the cabinet with magnets or screws. Each panel, again, modules plus cabinet, is put together like a large Lego using a base plate and bricks. The cabinet is the base plate and the footprint, and the modules are the bricks. The modules can be linked together to form any size or shape. Now I must mention this. Not all vendors follow this naming convention. Some vendors call the cabinets the panels and the modules the pixel cards. However, what is important to remember is that there are two basic components that make up all DVLED panels, and for the purpose of this discussion, those are cabinets and modules. So with that, I'll bring this training session to a close. I hope this information has helped you to understand a basic makeup of a DVLED video wall. Stay tuned for my next installment of Breaking Down DVLED Perfect Pitch, the importance of selecting the right pitch the first time. Thanks very much, and I'll talk to you soon.